Welcome everyone to our webinar. We think it's about number 396. And we think the eighth time we have Marek Quick with us, who's a global expert on science and academic work, the academic profession. And he does a great deal of comparative work, which is of value and interest to us all. I'll introduce Marek to you properly in a moment. His topic today is Quantifying Attrition in Science, a longitudinal study of scientists in 38 OECD countries. But let me first take you through the webinar protocols. Now, remember that the webinar is being recorded and it will appear on our YouTube channel, which you can reach through the CG website in the next day or two. During the webinar, we advise you to stay muted because extraneous noise can interfere with the presentation, and you don't need to have your camera on during the webinar either. We advise you to use speaker view, which is in the top right-hand corner of the Zoom screen, because that enables you to see who is speaking at any given time. Now, to join the chat that we have after Marek finishes his presentation, which is about halfway through the time, we advise you to use the Zoom chat function. Go into chat and post your question or your statement for Marek there, and then I'll be able to select you into the conversation we have after he finishes, when he answers questions and there's discussion. We do advise you to come into the chat early to indicate your willingness to enter the Q&A, because if you come in late, you may miss out. There could be a full speaking list by the time we get towards the end of the webinar in the last 5-10 minutes. So post your question or your statement for Marek early. When you're invited in, and I'll send you a little message in the chat beforehand, when you're invited in, you of course, turn on your microphone and turn on your camera if you can do that as well, and then tell us who you are, where you're from, and then give us your question or your statement. So, to Marek Quick. Well, Professor Marek Quick is the director of the Institute for Advanced Studies and the UNESCO Chair in Institutional Research and Higher Education Policy at the University of Poznan in Poland. His research area is quantitative studies of science, with interests in globalization, the academic profession, and international research collaboration. He's published extensively in these areas. He's got more than 230 papers and several books. Most recent monograph is Changing European Academics, a comparative study of science, social stratification, work patterns, and research productivity, Routledge. He's recently become a coordinating editor of the journal Higher Education. He's given seminars in Berkeley, Harvard, Stanford, Oxford, Beijing, Hiroshima in Japan, and Hong Kong. He's also had a past history in the US, where he worked at the University of Virginia and UC Berkeley, and he's been a Fulbright New Century Scholar and a visiting professorial fellow at the UCL in London. Currently a visiting researcher at the German Center for Higher Education, Research and Science in Berlin. We look forward to hearing from you, Marek. The screen is now yours.
It's all correct. Thank you so much. I will share the screen and start it right now.
We can see that. That's good.
Yeah, you can see it.
Yes, we can.
Okay, perfect. It's my great pleasure to be back again at Oxford, owing to Simon's hospitality. A number of critical maybe words from the title. It's certainly quantifying, measuring. It's attrition, disappearing or leaving science. But it's also longitudinal, studying individual scientists over time. And it's also 38 OECD countries, which is a huge part of the world. Main questions today. Can we really quantify the phenomenon of leaving science globally? I'll be trying to show you today that it's technically possible, and it's pretty interesting. I was very much interested in in thinking how global scientific community really disappears from science. People come and go, do research and disappear and stop doing research. But at the same time, I was thinking, is there any difference between men and women? Because traditionally, we tend to think there are enormous differences between men and women in attrition. Are there any differences across disciplines and specifically over time? Because in this presentation, I'll be working along cohorts of scientists. So there will be differences between those who started publishing at different periods of time in different years. So I'll be discussing something like 11 different cohorts of scientists. So the study is global, certainly, like almost global, 38 countries. It's certainly cohort-based. And it's also longitudinal, which means I have a number of limitations to show and discuss. It looks like this approach is working in practice with some interesting results, but still limitations have to be clearly shown. So to the final question, can we meaningfully track scientists over time, like for 20 years, 2 decades? Can we? My answer is yes, we can, but we need to use global data sets, which I will discuss in a second. So what we know today, and what I will be doing today, to an extent, is like testing traditional narratives about attrition, about leading science, with a new global data set. And what are these traditional narratives, and what do they say? First, it says, the narratives say, women tend to disappear from academia earlier than men. And second, women tend to disappear in higher proportions than men. And these, I would say, foundational narratives about higher education have been guiding policy initiatives in the mostly Anglo-Saxon world for 2-3 decades. So this is what we know from the past. But we, me and my co-author, whom I will discuss in a second, we come with big numbers. So we track scientists over time, and the numbers are like 400,000 scientists. So we have basically 2 cohorts: the cohort 2000, or everyone who started publishing in 2000, and cohort 2010, which is a decade later, everyone who started publishing in Scopus in 2010. And we track those individuals for up to 2 decades. So our approach is made available by Scopus raw data set, which Elsevier's lab, ICRSR lab, was kind enough to provide to us to do the computing. So why we are able to study attrition globally and longitudinally? The answer is simple. We can do it because we have access to digital databases. The data are around. I had several presentations also here in Oxford for Simon about us scientists leaving digital traces behind us. When we publish, we leave digital traces. And then people like myself come and trace these traces or analyze these traces, digital traces. Well, working with global data is difficult, is expensive, it's time consuming, we know it. But at the same time, using this type of data, we can construct lifetime histories at the individual level, a history for everyone in the data set. It's enormously interesting. I will show it in a moment. What can you say about everyone among those 400,000 scientists? Lifetime individual histories. So we do in this research, what we do is the exploration of career histories. Hundreds of thousands of individuals traced over time. Is leaving science a new scholarly theme? Well, it is not. It is definitely not. However, it was not examined as a theme both longitudinally for many years, year by year, and globally in terms of many countries. Traditionally, we know how it worked. Generally, leading science was discussed as through surveys, through interviews, through single institutional research or case study research. And the focus was for 3 decades on single institutions. And the sole point of interest geographically was the US. So whatever we know about leading science, about attrition, this knowledge comes from the US. It's almost 100% of publications. What we know from interviews, from surveys, we know why people leave generally. People leave because they find it difficult to keep the work-life balance. They find salaries low, or they find job security low, or they meet with discrimination in the academic workplace, etc., etc. There are different push factors and pull factors. Push factors are those which kick us out from academia or from the science sectors, and pull factors are those which attract us, maybe wonderful opportunities outside of the science sector or outside of academia. These are pull factors. So there's a combination of push and pull factors. And this is all we know about quitting science from surveys and interviews. And now we come with big data to this leaving science theme. So how it is different from what was done so far. First, on the right, you can see Łukasz Szymula from my post team, who just returned after seven months from the Boulder, Colorado in the US, from Aaron Closet's lab, and they do a lot of career studies there. So he's here. He's full-time co-author of this research. What is different in this research? Well, first, many countries, different geographical scale, not really single country focus, but focus on disciplines and on changes over time. I would say this cohort-based approach is really new. And longitudinal approach, this large scale longitudinal approach is really new. In terms of methodology, we use survival analysis. This is not new. It was applied to small scale research, survival analysis. When you leave science, what is the date when you leave science? After what time you leave science? Classical survival analysis. But we also use logistic regression analysis. So we see different predictors of basically staying in science in a multidimensional approach. Is this research strictly longitudinal? Yes, it is. When you define this design as following individuals over time for a long time, more than three waves, this is exactly what is longitudinal. And we have a lot of micro-level individual data. I will discuss it in a second. There's a wealth of micro-level data. We can conceptualize leaving science as an event. At some point, we stop publishing. We just disappear from science for good. We never publish again. And we conceptualize it as an event. So we use what is termed survival analysis to study this. We basically compute probabilities of occurrence of this event. When it happens that people disappear, stop publishing. And we know that in our sample, 90% of scientists publish something every year, 90%. And only 2-3% publish something every 2 or every third year. So it makes things easier for us. Certainly, we somehow revisit big theories. There are 2 big theories in this area, more or less, and they pertain to women. And I will be showing that we need to move to be thinking about scientists and not only women, because attrition, well, happens to everyone, which I will show in a second. The first theory is the chilly climate theory. Well, there is a hostile work environment in STEM fields, which can discourage women from even entering these fields. This is basically very much true. And the second theory is the leaky pipeline theory, which shows that there is a loss of talent at every stage of the pipeline. People come and leave the pipeline. There are biases, there's discrimination, there are barriers. These issues have been studied for 3 decades. But I would say mostly on small scale data, interviews, and surveys. Now, well, we come with global data set and we know there are limitations around. We discussed them for years. So these are all limitations. When we use well, in my case, Scopus datasets, raw data, we know there's a number of limitations, say language, English, STEM focus, science, technology, engineering, mathematics, medicine focus. This is certainly an old limitation, and we know it. But there are also new limitations, and I want to focus more on those new limitations. Limitations specific to this research on attrition in science. First limitation is, well, we conceptualize leaving science as stopping publishing. This is a huge limitation. We refer to publishers only, and we have no data at all about non-publishers in academia or in the science sector. That's a limitation. We also, to some extent, dismiss other roles. You may stop publishing, but you can continue to be doing teaching and service administration. With this type of data, with this type of approach, we are unable to say anything about it at the global level, just anything at the moment. So this in science status and out of science status is somehow slippery. We cut the story short, but the story is much more complicated. We simplify the story. We simplify what doing science means. We say that not publishing anymore equals to not doing science anymore, which doesn't have to be true. We can be mentoring, on reviewing grant proposals. We can do many things, but still in this conceptualization, this doesn't mean doing science. Well, so in general terms, what we do, we test structured big data, reliable, curated big data of the Scopus type, of the Web of Science type, of the new data sets type. We do it. Very briefly, the data, two big cohorts of scientists, the 2000 cohort and the 2010 cohort. In total, about 400,000 scientists with about 5 million publications. We defined their country of origin, their country affiliation, gender, discipline, etc., very carefully. This is the data set. And now, perhaps most interestingly, what can we know at every individual from this data set if we compute it properly? It's not the data from the Scopus data set, it's the data computed by us. So let us suppose we have all those scientists here with IDs, and if you look at ID here in this blue box, you can see a German scientist working in medicine. He's male. He's not really in top 200 institutions. He started publishing in 2000 and stopped publishing after 16 years. You can see it. He was a relatively well internationalized, so lifetime, in all his publications, a quarter of them were written in an international company. He was publishing in pretty good journals, pretty good. If you look at Scopus and percentile ranks from 1 bottom journals to 99 top journals, Science and Nature, etc., 72 is pretty high. He was working in pretty small team of 5 or 3 on average lifetime. He was pretty well cited. His citation impact was like twice the global average. And finally, he published 30 articles. This is what we can know, I wouldn't say easily, but we can know about our scientists in each case. For everyone from ID1 to ID, say, 400,000, we have this type of data, mostly lifetime, so computed from all publications available in Scopus. More technically for a second, we basically computed Kaplan-Meier's estimates for this population, for this 2000 cohort. You can see women on the left and men on the right, and you can see how years pass from year 1 to 19, and how the probability of staying in science is getting smaller. Here in red, you have probability of being in science in year 10. It's about 50% for men and about 50% for women. So after a decade of publishing, your chances to be in science are about a half. After 5 years, it's about 1/3. It's about 2/3 to stay and 1/3 to leave. So we did this type of calculations, which, well, technically speaking, look like this, but if we think about it graphically, it looks much more persuasive. This is exactly the same, but graphically. And on the left, you have the 2000 cohort, everyone who started publishing in the year 2000. And on the right, you have a much younger cohort, the 2010 cohort. So everyone who started publishing in these disciplines in 2010. And you see graphically the difference immediately. For the old cohort, the probabilities of women to stay after year 4 are always much lower than probabilities for men. And this is where traditional narratives were born. Women are leaving earlier, women are leaving in much higher proportions, and this is basically very much true. But when you look at the young cohort, the 2010 cohort, you see basically no differences. The stairs are overlapping. And if you look even more into specific disciplines, you see that in some disciplines, the differences are very high. Say biochemistry, genetics, molecular biology, the chances to stay in science or the chances not to leave science are much higher for men. But when you look at physics, at all those math-intensive disciplines, which I had the chance to discuss several times here in Oxford, math-intensive, like mathematics, computing, engineering, physics, astronomy, here the chances are equal. The curves are nearly identical. They're overlapping. So this is something we're not really aware of. Why would that be? I was thinking. You see, there's 4 women and a number of men around. And I came back to the theory of organizations with Cantor's stories from the 70s, when she was saying that when there is like 15% of women academics don't work as only scientists. They work as exemplary figures, representing women in the somehow hostile environment. Let's remember, it's physics, it's computing, mathematics. It's generally where these theories were applied, chilly climates. So our feeling is that the newcoming and surviving women in these areas are extremely talented and extremely hardworking from the very beginning. And this is the only explanation, or one of the explanations, why the curves are nearly identical in physics, where you can see the share of women is 15%, as opposed to biochemistry, where the share of women is about 50%. This is one of explanations. We did a number of approaches to this issue. We used different curves and different computations to see the difference. But whatever we take, however we look, and we have one set of approaches for cohort 2000 at the top, and another set of approaches to cohort 2010 at the bottom, you see immediately the difference, at least graphically. Years ago, there were important gender differences, higher chance to leave, smaller chance to stay, etc., etc. Today, with younger cohorts, these differences are just disappearing, and this is the figure at the bottom. So results are much less gender sensitive today, much less. So what is the answer? Why this is happening? Attrition patterns are less gendered over time. We studied basically 11 cohorts from 2010, 11, 12 to 2010. From 2000, 2001 to 2010, 11 cohorts, like 2.2 million scientists. And we realized that scientists start work and start publishing in different, well, conditions, under different, well, say conditions. So our conclusion was that time in science matters. Environment changes, and we need to realize that what was visible 20 years ago for one cohort is not really visible 10 years later for another cohort. The findings valid once may not be valid today. This is how science changing. It changes fast. So time really matters. We don't really do national studies here in this research, but still we prepared an interactive dashboard, how probabilities differ between countries and between disciplines and between cohorts, 11 cohorts here, and over time. So you can see it visually that, for instance, career prospects in different countries are absolutely different. This is an example of women in medicine. When you think of Germany and Austria, the chance to stay is 40% after 10 years. But when you think of Estonia and Lithuania, the chance to stay is like 90%. And we have this type of data for every of the 38 countries in our data set. So this is, well, one-time national approach, which we don't use. It doesn't even appear in the preprint or in the paper, but still it is doable. You can do it by country. And this dashboard is available online. The address is here, just to see how career prospect looks in your country, for your discipline, for different cohorts. And finally, I will discuss very briefly logistic regression analysis and conclusions. First, what I was saying until now was more or less two-dimensional. So we had men and women and disciplines and time. And now I want to show you the results from a multi-dimensional perspective. So we have many predictors, and we have the stayers and the leavers. And we are analyzing what helps you to be among the successful. The success is to be among the 30% of leavers. So from this cohort 2000, only 30% of scientists left. We know it. Okay, but why they stayed in science? What are the predictors which made them stay, the stayers, as opposed to those who left in the meantime, just disappeared? The leavers, the 70% of the other. So we were thinking, is career really predictable, more or less? And we looked at the literature, which we know pretty well because I discussed productivity for many, many years. So I was thinking, what matters? Well, probably to stay in science, high research productivity should matter. You produce a lot, you stay in science. I was thinking, well, publishing in high impact journals matters. You publish in good journals or very good journals, your chances to stay are very high. And finally, I was thinking gender matters. I was thinking it's much easier and much probable for men to stay than for women, which was based on traditional literature on attrition science. And this is not exactly the case. So I was trying to estimate odds ratio of staying in science for those stayers, 30% of stayers. Very briefly, maybe the details are not that important, except for a few messages. One message is powerful. Publication numbers matter. They are the most influential predictor of publishing in the following year, which means staying in science. An increase of publications by one, and I mean only the journal articles, increases the odds of the chances of between 10 and 20%. So publishing matters a lot. This is quantity. And when we think about quality, does it matter? We have really two variables here. One is about citations. It is FWCI for 4 years. And another is about average publication journal percentile, which is more or less prestige of journals. And looks like publishing in very, very good journals matters a lot, even a lot, compared with publishing in bottom journals. But citations don't really matter. And perhaps most importantly also, gender among all those variables doesn't matter much. So being male does not really increase your chances to stay. And this is extremely interesting because we're thinking it matters a lot. So conclusions and final words. I would say these results are somehow surprising. We are still all living in among conceptualizations from the past 2-3 decades and among approaches which were popular in the past decades. And now we have a large-scale data, which is new context, and national literatures, mostly American, excellent literatures. And we have to combine the two somehow. And it's very difficult to combine the two. We either say we have new data which may lead to a revision of past theories, or we may say we keep the two because the literature is American and this study is global. There are many choices to go on with the results. Well, the role of gender is much more than expected. In the presence of other variables, being male is not a statistically significant predictor in almost all disciplines. It just doesn't matter. This is highly encouraging conclusion. Also, quantity matters, but quantity looks like being more important than quality. So when we talk about quality, it's only very top journal, very high level journals, which makes a difference. And when you consider bottom level journals and middle level journals, the difference is not that big. So quality related independent variables are less important than expected. And this is really, really surprising to me. A few methodological takeaways, one slide in final words. As you may know, we did a lot of national level studies. You have bibliometric data about Poland, and you have administrative biographical data about Poland. As scientists have about the US, academic analytics, or Norway, Christian, it's possible to do a lot of things nationally. And we do it. We do it routinely, and we know what can be done. But doing global studies, we also know immediately what cannot be done. For instance, we don't have biographical information. We don't have year of birth, employment history, promotions, which we do have when we think only about the US or only about Poland. So here, global is not available. We don't have national registers of scientists. We use only publishers or publishing only scientists. It makes a difference. While locally for Poland, you have perfect data, perfect biographical data, because they come from registries. Now we have inferred data, like women, 90% probability, or whatever, inferred data, proxies, not really perfect data. But the idea is to really move beyond national analytical containers. In this case, really move beyond US literature. All we know about attrition in science and in academia comes from the US. Here we move towards, well, a global picture with 38 countries. There are trade-offs, but we believe it's important. And final words. Well, if we want to move beyond single countries like the US and see the changes over time, as we did here, we need longitudinal global data sets. And there are no other data sets except for bibliometric at the moment. We know also that attrition means different things for men and different things for women in different disciplines. We studied every discipline separately, and we had these nice curves and nice tables for every single discipline separately. So we know that attrition is not everything for everyone, and it's not the same. But we also know, and this is somehow new, that attrition means something different for different cohorts. If you are cohort 2000, and if you are cohort 2010 or 2015, your chances to survive are just different because times is changing. So finally, to conclude, gender differences in attrition are getting smaller, and this is highly encouraging. It's only about attrition, not participation, but it's encouraging. We have new data about people working in new conditions. There may be policy implications, but it's not the time for me to think about policy implications because it's at the moment it's pure research. Anyway, we know that attrition is very high, and we know it's too high. It's like 60% of us scientists disappear within a decade. I would say it's enormous loss of talent. It's high and it's on the rise. But most of all, and this is the final 2 words, 2 sentences, attrition is an issue not only for women. Attrition is an issue for both men and women, because we both sexes, just everyone is disappearing from science. And this is an issue which I studied for at least 15 years: job attractiveness, working conditions, career opportunities. All these matter to all scientists, and increasingly so. So why we leave science? Well, we don't know. We have some good data, big data analytics, good everything based on large-scale data sets, but we don't know the simple question why. And here I believe qualitative studies can help. Interviews, again, surveys, again, national level studies, again, not only from the US, but from many countries. So I believe, which I expressed as an idea many times here, I believe in a combination of methodologies, quantitative, qualitative, big data, interviews, surveys, all in one. In this case, to study living science. Okay, thank you so much. I believe it's perfect timing, and I would be happy to have your reflections or comments or whatever you suggest.
And Marek, we have 5 people already lined up to raise different issues with you. So you've stimulated a lot of thought and a lot of questions already. So thanks for that really splendid presentation. Great data. Well, the clarity of your presentations is always exemplary, and it will bear repeated viewing on YouTube. So you can be sure that this is a valuable resource for all of us. I think these webinars are a little bit more visible in some respects than a journal article, because they allow you to, make really clear certain points and illustrate your data very well,
Exactly.
and give a bit of a human flavor to the whole process, which doesn't do any harm. I'm going to quickly ask you 2 questions together, and then we can move down that call list, which is now up to 1, 2, 3. It's still 5 people. Firstly, we know that, as you've said in the past, I think that a large proportion of science, and a large proportion of very good science, very highly regarded science, if we use citation as a measure, is or journal placement and journals ranking as a measure, is done by a small number of people, small proportion of the total scientific workforce. Do we know that that the patterns of longevity are different for those kinds of scientists compared to all scientists? And the second question is variations by country. I know that this is a difficult question to answer conclusively and simply when you're looking at 38 countries in a data set, but are there things that jump out? Do your conclusions modify substantially in certain countries?
Yes. Both questions are excellent and hard to answer. Still, what we know about the stayers, this 30% of scientists who really stay after 20 years from this cohort 2000, we know quite a lot about them. And we know that more than 90% of them, 95% of them publish at least once a year, or 5% of them publish once every second year. So they publish a lot. We know from regressions that they publish in relatively good journals, and when they publish it in much better journals, the chances to stay are much higher. I understand your question is about the differences in chances of staying between, well, so to speak, top performers and the rest. We are studying only one-time publishing, so we don't really study productivity in this research. We did another research about, well, how to enter the classes of top performers. Here is only publishing once a year, or not and stopping publishing. We don't really see big difference in the patterns regarding those who publish a bit and those who published more before they disappeared. We just know that 1/3 of scientists, no matter what, publishes for the last time ever, and half of scientists after a decade publishes for the last time ever. And it's not about coming back to science. They never come back to publishing, never. So this is important to stress. And this is probably what we can observe in our universities. But this story, Simon, is about the science sector. We can cut it to academic sector, to universities if we want, through the data. But generally, it's publishing. It's publishing. So either if you're in a company or you are in academia, you either keep publishing or stop publishing. And this is the major issue. And now about the countries. Okay, we have 38 OECD countries. We were thinking generally about the top 20 and the rest, just to use agglomerations of these countries. And this story was supposed to be global story, because we have a lot of stories from the US, okay, easily. And they were produced in the past three decades. And we have nothing about other countries. Our approach was to visualize what we know, because it's somehow difficult to discuss the clusters of countries in this type of research, but still we observe some patterns. For instance, in former in former communist countries like Central and Eastern Europe, the chances to survive in science were very high. So once you started publishing 20 years ago or 25 years ago, your chances to stay are high. And after a decade, they're also very high, as opposed to Austria, UK, Germany, Switzerland, where the chances are much smaller. But still you have a number of dimensions, chances in medicine or chances in chemistry, which we know it from our research, which cohort, the oldest cohort, all those cohorts in between. It's so multidimensional that finally we need models to say something meaningful, because there are too many, I would say too many dimensions. And still, if we look at the pictures, the patterns are there.
Thanks for those comprehensive answers. Really appreciated, Marek. Our first question's from Jose Prieto. Jose, can you come in, please? There he is.
Yes, thank you. Thank you very much for your presentation. Very insightful. I would like to ask you two things, and is if you consider including and controlling your logistical regression about international collaborations, if more connected scientists has a longer period in or staying in science. And the second one, the success of scientists in getting funding or getting grants. So if you had any controls on that.
Yes. Well, again, both questions excellent, really penetrating. As you know, we had micro level data about everyone, about their international collaboration, again, through the proxy of co-publishing with international partners. So it's again a proxy, but it says something. Your rate can be from 0, no internationally collaborated papers, to 1, all papers internationally collaborated. And we use this variable in the model, and it shows that really increasing your rate by 1 unit increases your chances to stay in science by less than 1%. It looks marginal, but when you think about 2 scientists, one with 20% rate of international collaboration, and another with 75% rate of collaboration, which is unit difference of 50, it makes your chances in the second case 50% higher. So international collaboration is enormously important for staying in science, but only for those divergent cases. When everyone is more or less collaborating a bit, it does make a difference. But if you collaborate enormously, like your rate is 0.8 or 0.9, your chances are much higher. So it's important. And you can see it only through the model. And the second question was
sorry, about funding, about the success in funding.
Excellent. You can do models and you can study funding at the moment, mostly with Web of Science data. But the Web of Science is not focused on scientists. So it's much more difficult to do what we are doing with Scopus. So it's either or. In Scopus, there's not enough data about funding. So we couldn't be using it as a variable. But I know that Scopus is generally adding funding data. So in a few years, there will be newest data and older data updated about funding. I don't believe it's really, it will change. It will be a game changer, but it will be possible to use funding data in the model. What we can do is, again, nationally, think of Poland. People, biodata, administrative data, funding data, everything. Every possible model is possible. But when you move to global study, it's, again, much more complicated. But we test all ideas nationally first.
Thanks for the question and the answer, Marek. Yingxi Zhao is next. Yingxi, are you there, please?
Yeah, thanks. Thanks for a great presentation. My question was related to how have you accounted for researchers' name changes, which might have specifically influenced female researchers' name changes of their last name before and after marriage or divorce, and which might have impacted some of the gender-specific studies, and might also relate it to different time of cohort or different disciplines.
Yeah, thank you so much. As I said, when you treat this phenomenon, but also other phenomena like productivity or whatever globally, you need to make a lot of proxies. One proxy is, say, gender, 90% women or 90% men. It's a proxy. And another proxy is, well, people generally stay with their names or with their two names, as in many countries. In many countries, females keep their male names for years. There's no single way right now to take these changing names into consideration, and unless Scopus is taken into consideration. So Scopus is a, well, generally Elsevier is a multi-billion dollars enterprise. If they think it's possible, they just do it and they merge the data. If they don't do it, we can only say we will never do it with our resources. So again, we use proxies. We know some percentage of women change names. We know it, but it's very difficult to use it at the level of individuals. So my answer is no. We didn't use it in our models or in our thinking at all. At the moment, it looks like it's just impossible. It's one of those limitations of bibliometric type of studies. Once bibliometrics solve this problem and big data providers like Scopus solve this problem, we are able to use it, but not at the moment.
Yep, thank you.
You're welcome.
And our next question is from Jim McKinley. Come in, please, Jim.
Thanks, Simon. Thank you, Marek. I really, really appreciated this whole thing. I think the way that you do your work is always really fascinating in terms of being able to control for all of these different variables. I think the questions that Jose and Yingxi raised, are significant because I think, these are all further ways of kind of thinking about this research and ways that we can use it. My question was in relation to how we can use this research with some of the qualitative data out there. So recognizing, that this is quantitative. It's interesting trying to publish some of my qualitative work. I get feedback from reviewers saying, please add quantitative data. And I always, and I kind of look at this because I think I see such incredibly large differences between some of the findings of the quant studies versus the qualitative studies. So the point that I wanted to raise was in relation to this finding that the statistical insignificance of gender difference, I think is promising, but then it completely challenges the qualitative findings about a lot of the work that doesn't come out in the quantitative research, the kind of invisibility of these gender differences and their roles, not to mention, especially in the fields that this study was conducted and the number of women involved in this research. So I wonder about how you see being able to apply some of these things to that area of discussion in the field.
Yeah, that's a great issue. I'm thinking about ideas provided by mostly qualitative research. So all theories and conceptions and ideas come from qualitative research, and this is the treasure of the past 30 years. Perfect. But we also know these studies were small scale, institutional focus, US focused, most year only. Okay, so there is a combination of uses of big data and ideas from small scale research which has to be thought over. I would never dare to produce theories based on big data because I know the real stuff comes from qualitative studies. And this is the difference between how qualitative research works and a quantitative research works. When I read large-scale quantitative studies, what they in Science of Science, what they do, they use our theories from qualitative studies as a background, which is a literature review or prior research, what I was doing somehow here to an extent, and they say, okay, our large-scale studies show something else. But this is not enough. I'm trying to really link quantitative and qualitative studies through large-scale surveys, large-scale meaning large-scale, and through even large-scale interviews, not 50 or 100, but say several thousand, which is a difficult technical AI issue, which I'm not going to discuss right now, but this is a real combination, which I'm thinking about, qual-quan, big numbers of interviews, really big. and huge global surveys, plus this type of data analysis. I see this is one of the answers, but we will never forget about ideas coming from, these 50 interviews or even 20 interviews where big ideas appeared and where they're promoted for decades. We need to remember where Merton came from and where the Koch brothers came from, and Harriet Zuckerman talking to Nobel Prize winners or talking to scientists. This is where ideas were born. So, okay, this is my answer for now.
No, thank you, because I think this is the thing about, being able to pull in some of these qualitative factors, right, that challenge them, but of course they're so small. But no, that's excellent. Thank you so much.
Thank you.
Very encouraging to hear you say, Marek, that the theories and concepts have largely come from the qualitative side, and you to some extent make me feel comfortable about my own professional choices. So thank you for that. But I do think that quantitative work like this gives us such a grasp of the overall social picture. It's so valuable in that way and persuasive, I think, for that reason. So the two definitely belong in the same universe, and they feed each other, we hope, on a good day anyway, rather than going down completely separate tracks, as often seems to be the case. Okay, so let's bring in Alina Nefedova. Good to have you in the webinar. Good to have you again.
Thank you a lot. I really enjoyed your presentation, Professor Quick. I have 2 questions, actually. First of all, have you considered merging data from ARKit to fill the gap about employment history somehow, maybe for the small scale, maybe for some cohort, just to go for those who left the science and maybe continue to, I don't know, work as a teacher, as you said. And the second question is about business sector. You've mentioned already that you consider publication both in business and academic sector, but based on your expertise, is there any hypothesis where chances to stay in science are higher, in business sector, in the R&D, or in academia? Thanks a lot.
Okay, thank you very much. Well, we know that more than 90% of publications are produced in the Scopus universe, are produced in the university sector. So the business sector is somehow marginal. We can cut the data so that we focus only on academia. And it's possible. Then our story would be academic profession, not science profession. But I prefer the larger story about science profession. When you ask about employment histories, this is this moment when we have to use proxies nationally, as in Poland or in the US or in Norway. You have full employment data. People come and stay and do their promotions, and they leave from a given university. It's possible nationally, easily. And we use it in our studies about Poland easily, like, steps in progression, moving up the academic ladder. But when we move to the global study with 38 countries, it's almost impossible to think about employment. So let's forget about working. We can only focus, as I can see it, on publishing or not publishing. So you can be in your university for life. As long as you don't publish, you are in this type of research invisible, because there's no way to see you in this big picture and to see you in the dataset, because you are out of this dataset. I believe in new datasets produced in the future, which will go beyond pure bibliometrics, but I can't see it now. So as is, we basically study publishers, and we forget about necessarily non-publishers. This is a major issue, but if we are unhappy with this, we do national studies, as Americans do studies using academic analytics dataset, commercial, expensive, but it's available. And as I'm using Polish data, non-commercial, not available, but I have it. And this is full employment history from, first PhD to your retirement. But globally at the moment, it just won't work.
Very nice. Thanks for the question, Elena, and thanks for the answer again, Marek. Renee Kremka, you're next, and please come in.
Yeah, thank you too, Marek. I'm thinking about explaining the big differences between the countries, despite the restricted count of the countries. And that's why I'm thinking about if would it possible by multi-level analysis and to integrate in this way some data about working conditions, also gender regimes, and maybe it could explain the big differences. As you know, countries like Norway have a more social democratic gender regime, and countries like my own, nice greetings from Berlin too, southeast of Berlin, is more a conservative gender regime, and Austria too. And maybe it could explain it and some other data like working conditions. What do you think about it?
Yes, I'm thinking a lot about it. I'm thinking about focusing for a moment on Europe, except for doing big global pictures, because for Europe, all this type of data you mentioned or allude to are somehow available. So when we focus in Europe, generally, we have, for instance, this RESIS infrastructure or this Ether databases about 3,000 universities. We have full data coming from European Commission about, well, social conditions in a country, in any country, in any European country, as a context. We also have full data or a lot of different types of data about each institution, like 3,000 institutions. We have student numbers, research funding, teaching orientation or research orientation or whatever, access to research funding or access to any funding. So there's a lot of data within Europe, but it's going to be a story about Europe, which is a different story. Perhaps it would be useful to compare Europe to the US or Europe to the Far East, but I'm not sure this type of data would be easily available about other parts of the world except for Europe at the moment. And also, I wanted to stress this is a very preliminary work. It's testing ground. I mean, we somehow discovered turning a bibliometric data set, which is big data, structured data, turning it into a academic career data set. We just started to be opening it, and we move in different directions. One direction is attrition. It's finished somehow as a story. Another direction is changing productivity classes over lifetime. It's finished somehow. Another direction is self-citation, men overciting themselves compared to women, also globally. There's a number of ongoing research here, either finished or almost finished. And then you stop for a while, and then you think, okay, maybe we'll focus using the same data sets and other data sets merged. Maybe we'll focus on Europe. But at the same time, we do everything about Poland to see what works, what doesn't work. And it's just a couple of us with one PI, that is myself. Yeah, we can think a lot, but still we have to do what we do. But yes, this idea of focusing on countries is important. Poland done, Europe possibly done very soon.
Sounds encouraging, Marek. Juliet Sweeney, can you come in, please?
Good morning. Thank you so much for your presentation. I'm going to leave my camera off if that's okay. I can't wait to play with the map. It's really interesting to me to see this compared across countries. One of the things that struck me, though, and my research focuses on graduate engineering education, that you would think that if women are publishing just as much and just to as higher quality, then one would hope that the representation in academia would be proportionate. And I think it's lovely that you've done the 20 years, so we have that longitudinal view. I'm not expecting you to speak to this directly, but I was just thinking it would be interesting to look at a discipline level and see if this pattern of underrepresentation is specific just to engineering, or if it actually is evident in A, other countries, and B, other disciplines.
This is a lovely question. We just published last week a big story in quantitative science studies about the participation of women in science over time. Again, OECD countries, again, 16 STEM disciplines. And what we learned from this, that a real balance between men and women in science, and especially in this engineering, mathematics, computing, astronomy, physics will take another 100 years if the trends are as they are now, the trends of the past 30 years moving to the future. But this is about participation. One thing is to enter the field, another thing is to stay in the field. And in this research, we studied staying in the field, like what makes you stay and not disappear. And in those very specific cases you mentioned, your engineering, but also, mathematics, computing, blah, blah, blah. In these areas, once you enter it, your chances as a woman or as a man are exactly the same. The probabilities to stay or to leave is exactly the same. And this is a big four, which I often mention, big four in STEM, as opposed to all other STEM disciplines. If the explanation is, as I said, small number of women, which goes against participation. Perhaps if there are as many women as in biochemistry, the chances would be as different for men and women as in biochemistry. But this is a complicated story. We think about it a lot.
Mm-hmm. Thank you.
It was great, Marek. I think, that if you've done 8 for us, and we're almost at the point of putting out a greatest hits album, this one will figure prominently in the on the disc, one first or second track, perhaps. Great to have you on the show again. And can I ask you a final question? What else are you working on, and what are you doing next?
Okay, just one. Okay, ideally, we are just finalizing preparations of the global survey, which I mentioned 2 years ago, but it takes so much time to prepare the survey. So we do a global survey of the academic profession, like 2 million academics who published in the past 2 years. Then we think about large-scale interviewing scientists based on AI technology. So we don't want to interview, 100 scientists. We want to interview 3,000 scientists. So this is something enormously promising today. In terms of topics, it's this men oversighting women globally over time, always big difference, and it's aging, or it's how scientists age across countries and disciplines. And it can be too much at a point, Simon. It's more than enough right now. So I don't jump to what we'll be doing in 2 years from today, because I can't say.
Well, no one knows the future, Marek, and but all power to you, and keep going, and you're doing wonderful work. So, and of course,
thank you so much.
Yes, you'll be most welcome to come back onto the CG webinar program, which will continue after the funding period stops on the 30th of April. We'll continue into the future beyond that. So
fantastic.
I'm sure that everyone will be very keen to hear from you as many times as possible.
Thank you so much.
The next webinar, folks, is in the series is on Thursday. It's on the 1st of February, Thursday, 2 p.m. UK time. And the topic is social science research in India. Navigating the borders of global and local terrain, interview-based study. I'm familiar with the study. It was done by a master's student of a very, very good master's thesis by Vedika Kedia at Oxford. And we're looking forward to having Vedika on the program in 2 days. And we'll see you all then. Thanks, Marek, again, and bye for now.
Thank you so much. Bye-bye.